Ever looked at your PC and wonder why 15 cores are chilling while Python is stuck on one? That's because of a famous feature in CPython called the GIL. But in 2025, something huge is happening. Python is finally learning to run threads in parallel, for real. CPython, the standard Python interpreter, has a lock called the Global Interpreter Lock, or GIL. It keeps Python's internals simple and safe. But it also means only one thread can execute Python bytecode at a time. You have probably heard this rule of thumb. For IO-bound work, like networking or file reads, threads help. For CPU-bound work, like number crunching, threads don't scale. So devs jump to multiprocessing, native extensions, or other languages. PEP 703 proposes making the GIL optional. With the new free-threaded build, threads can finally run across multiple cores. In Python 3.13, free-threaded appeared as experimental. On Windows and macOS, you could install it as an option. By Python 3.14, it's officially supported. Not experimental anymore. It's still optional, but a huge milestone. To check if the GIL is enabled at runtime, Python added sgil enabled function in the system library. On Windows or macOS, install Python 3.13 Plus and enable the free-threaded binaries. You will see an executable with a T suffix, like Python 3.13 T. Let's try a simple CPU-bound demo. Spin up a few threads doing heavy computation. On classic CPython, you won't see true multi-core scaling. On free-threaded Python, you finally can, depending on your code and libraries. Results vary by machine. Free-threading can add overhead in single-threaded cases, but the win is real parallel threads are now possible. Here's the catch. Packages with native C, C++, or Rust extensions often need free-threaded specific builds. Look for the T suffix in wheels and binaries. For example, ABI tags like CP313T. The GIL isn't always gone forever. If you import an extension that isn't ready, Python may re-enable the GIL, unless you force it with an envvar or flag. To stay ahead, test your project under free-threaded Python. Don't rely on the old GIL keeps me safe myth. Use proper logs for shared state. Track whether your dependencies ship T views. This is one of the biggest shifts in Python performance in decades. Free-threaded Python won't magically speed up every program, but it changes what is possible.